As part of the CERCOM project, a risk-based framework and software tool were developed in Microsoft Excel to facilitate circular procurement while assessing the technical risk of incorporating novel or innovative solutions into design, maintenance, and construction of road infrastructure. The goal is to provide a means to assess current practice and the potential benefits of more circular solutions in increasing resource efficiency, minimizing waste, and reducing the use of virgin materials. This video provides an outline of the risk-based framework and the associated software tool developed as part of the CERCOM project. The goal of the risk-based analysis framework, or RBAF, is to facilitate circular procurement and provide a means to assess current practice as well as more innovative solutions. The developed framework has 5 steps. The first is establish context to outline primary goals and the spatial and temporal boundaries for the scheme. Next is evaluate likelihoods, which involves quantifying the probability of failure for a particular limit state or failure scenario. This can be done in different ways, using expert knowledge, decision trees, or probabilistic models. Since risk is a product of probability of failure and associated consequences, the next step is evaluate consequences to assess the direct and/or indirect costs associated with a failure scenario. These steps are all standard practice in a risk assessment, and what we have done in CERCOM is add a further step to establish additional KPIs to account for circularity, environmental, social, and economic factors. The final step in the process is optimization, where data and key performance indicators, or KPIs, from all steps are consolidated and optimized, providing the user with a single metric to rank potential scheme options. As part of the RBAF and software tool, the user can compare up to 3 schemes. To quantify and compare the benefits of each scheme, 5 categories have been established: performance, cost, resource efficiency and circular economy, environmental, and social. Within each of these categories, single or multiple KPIs can be defined depending on the scheme being considered and the priorities and maturity of the NRA. Each criteria or KPI established must be assigned a weight between 0 and 1, and it is essential that the sum of all weights is equal to 1. Once all the relevant data is entered, the optimization and ranking of options can be completed. Within the developed software tool, these factors are combined into a single metric called the Net Risk Reduction Gain, or NRRG, a weighted sum giving the user a clear indication of the optimal solution from a range of potential options. The Risk Reduction Index, or RRI, is used to quantify the technical performance risk associated with each option, using the do-nothing scenario as a baseline reference to provide a value between 0 and 1. The Cost Performance Index, or CPI, can be used as a simplified method to incorporate economic factors using the capital cost and/or indirect costs for each option, and the budget available as the reference. For more complex analysis, the CPI step can be skipped, and economic analysis can instead be incorporated as an additional KPI, for example, using whole life costing or net present value. To calculate the NRRG, each index or KPI incorporated must have a value between 0 and 1. The additional KPIs included in the analysis can be defined and incorporated using the ranked interpolation method. This provides a robust and stable means to incorporate multiple criteria while ensuring a similar sensitivity for each factor being considered. To define the relationship between the measurement values and the KPI values, data must be provided by the user to establish up to 4 ranks. The software tool then uses multilinear interpolation to calculate KPI values for each option. In its simplest form, there is an option to provide just 2 ranks with upper and lower thresholds for each criteria considered. Linear interpolation is then used to determine KPI values for each scheme option. A software tool was developed in Microsoft Excel for the practical application of the RBAF. The goal was to provide a user-friendly, intuitive tool to suit all levels of maturity. The tool is presented in 3 tabs. This screenshot shows the outline of the first tab, an introduction providing a brief description of the model and some instructions and assumptions. Just to note, a full user manual was developed to accompany the software tool, which provides a step-by-step approach to outline the use of the tool in detail. The second tab is where the user provides all the data required for analysis. The capabilities of the software provide flexibility to the user with the ability to choose the level of complexity required for a specific scenario. Preset options are incorporated to provide the ability to include empirical evidence where sufficient numerical data is not available or where a quicker, more simplified analysis is required. The final tab then provides the results of the optimization. The results are provided in tabular and graphical format, demonstrating the impact of each of the criteria considered in the overall result. I will go through some of the details on the practical use of the software tool, although a more detailed demonstration video and user manual are provided within the resource pack. The software tool allows the name of up to 3 scheme options to be entered. We've used option A, option B, and option C in this example. The do nothing scenario is also required as a baseline reference for the risk analysis. Using this table, the user provides the input format for the data to be entered. Within each assessment category, performance, cost, resource efficiency and circular economy, environmental, and social, the user can input the names of the specific criteria or KPI to be considered. Once the name is entered in the grey column, the corresponding cell turns from green to white, indicating further user input is required. In this section, the user is requested to provide the input format for each criteria. The options preset scale or numerical input can be selected from a drop-down menu for each option. The numerical input option requires more data but can provide a higher level of confidence and accuracy in the final output, depending on the quality of the data provided. Regarding the risk assessment for each of the options, the examples here will demonstrate how numerical input and preset scales are utilised. The risk is the probability of occurrence of a specific failure event multiplied by the consequences associated with that failure. In this case, it's expressed as a cost. A failure event could be a loss of skid resistance, for example. Using the preset scale, the user selects the estimated performance level from 3 options: above average, average, or below average. To take account of the level of confidence in the selected performance level, the user can also select the uncertainty associated with this input, selecting from the options low, medium, or high. Alternatively, the user can perform analysis using decision trees or probabilistic models, for example, to determine a numerical value for the probability of failure, and alternatively, this can be entered and inputted into the cell indicated. The consequences of failure, then expressed as a cost, must also be entered for each scheme option. The following images illustrate the ranked interpolation procedure within the software tool. For each KPI or evaluation criteria, a minimum of 2 ranks must be defined, providing upper and lower thresholds. The lower or less favourable threshold is assigned a KPI value of 0, and the upper or more favourable threshold is assigned a KPI value of 1. Where a more complex relationship is required, 3 or 4 ranks can be defined and multilinear interpolation can be used. Once these ranks are defined, the measurement or data values for each option can be entered by the user. The ranked interpolation method then provides a means to translate the data for each scheme option to a value between 0 and 1 as required for the optimization step. As discussed, a preset scale is also an option for the additional KPIs. It wasn't feasible to provide a tailored scale for all possible criteria. Therefore, a generic scale was generated to provide a means to incorporate empirical evidence for all potential KPIs. Using a drop-down menu, the user can select between the following KPI values: 0, 0.1, 0.25, 0.5, 0.75 and 1. A general description corresponding to these values is also incorporated to provide guidance and some form of consistency when using the preset scale. The descriptions corresponding to each value, with examples relating these values to specific examples for recycled content and working hours, are provided in this table. A copy of this table is also provided in the user manual for reference. As discussed previously, it is essential that each KPI or criteria considered is assigned a weight between 0 and 1, and the sum of all weights for each scheme option must equal to 1. In this area of the spreadsheet, the user is prompted to enter these values in the white cells indicated. Only values between 0 and 1 are permitted. If the sum of the values in each column does not equal to 1, an error is displayed and the user is prompted to revise input values. In the final tab of the spreadsheet, the user can access the results by pressing the button indicated. If there is an error with weights, the results won't be displayed and the user is prompted to revise inputs. The results are presented in a table and a graphical format as shown, with the highest result or higher N or G value providing the more optimal solution. The graph presents a clear breakdown of the results for each scheme option, allowing the user to assess the impact of each KPI considered. It is advised that the user interprets the results taking account of the quality of information provided for the assessment criteria under each of the categories. Further resources related to the RBAF and associated software tool are provided on the CERCOM website. There is a software tool and user manual, reports outlining project deliverables. There is a short summary video of the RBAF and a demonstration video of the RBAF and software tool. Thank you for watching.